Hello, today we're looking at resultant forces. In this picture we have a tug of war competition and each person is pulling in the same direction. There are multiple forces on the rope. When we talk about the resultant force, we mean the overall force. So where we have a number of forces acting on an object, it can be replaced by just a single force that has the same effect on all of the original forces added together. So if I replace each person with an arrow pulling in the same direction along the rope, and let's assume that each of the 6 people pulling has the same size force, for example 20 newtons. So all of those forces in the same direction add up to make one larger resultant force. So we can move the forces so they're next to each other top to tail, and it can be replaced by the orange arrow. So if 6 people each with 20 newtons is pulling in the same direction, that can be replaced with one arrow of 120 newtons, 6 times 20. Note that the length of the arrow is linked to the size of the force. The longer the arrow, the bigger the force. So once you've calculated the resultant force, you can work out what the object is doing. So if there is a resultant force, so there's a number left over, so in the example we had just now 120 newtons, the object would either speed up or slow down. The object would either accelerate or decelerate. If there's no resultant force, so if the arrows cancelled equals 0 newtons, the object's velocity stays the same. And what we mean by that is it's either stationary, so it's staying at a constant velocity of 0 meters per second, or it's moving at a constant velocity, so it's moving. If we look at another example briefly, we have a skydiver with his parachute open. We have the weight pulling the person down and air resistance acting in the opposite direction because of the parachute. Let's assume we have 800 newtons of weight and 800 newtons of air resistance. Notice those forces are acting in the opposite direction. In this case, because they are in the opposite direction, the forces count against each other. In this case, they would cancel out, so the resultant force would be 0 newtons. That means our parachutist is falling to the ground at a constant velocity. There is no overall resultant force acting on the object, therefore it does not accelerate or it does not decelerate. Constant speed. In this example with a Formula 1 car, there are often more than one force acting on the object. So we might say that the engine gives the thrust forwards, but then there's air resistance back and there's also lots of friction between the tyre and the road. But in addition, at right angles is the weight of the car acting from the centre of mass, and the opposite force to that one we might call the normal contact force. It's then useful sometimes to draw what's called a free body diagram. That's where you turn the object into a dot. In this case, it's a blue dot in the middle. You can then align all of your forces from that central point. Let's say that the weight down has a value of 8,000 newtons and the normal contact force is also 8,000 newtons. So the forces are therefore balanced. One cancels the other in the up and down direction. So that's why the car doesn't sink into the ground, but also doesn't lift up into the air. We would say that the up and down forces are independent of the forces going left and right at right angles to each other. So we would treat them separately. So now we can look at the horizontal direction. If we say the thrust is 75 newtons forwards, the air resistance is 25 newtons and the friction is 50 newtons. The air resistance and friction going backwards also adds up to 75 newtons, which is equal to the thrust of 75 newtons. So therefore, also in the horizontal direction, we have balanced forces, 75 forwards and 75 backwards. So that means our car is also moving at a constant velocity. So it might be stationary or it might be moving very fast indeed, but certainly not accelerating and not decelerating. So to finish off, to find the resultant force, you need to add together all the forces acting in the same direction. You take away or subtract all the forces acting in the opposite direction. And at the end, it's important to say the direction that the resultant force is. So that might be it's moving left, moving right, up or down. As ever, if you found that useful, please remember to press the subscribe button to get notified of any future videos that are made.